Okay, so in the previous session we were looking at the implementation of various gates, the logic functions using the MATLAB, and we could also implement the same functions using various activation functions. Right? That was something like a very basic exercise for us to check and to check the functionalities of MATLAB, and just to check, right, how to write these functions on a MATLAB screen. Okay, so now our next intention is to implement slightly complicated algorithms in MATLAB. All right, something like a delta learning rule, which we had seen earlier in the theory class. Okay, so today we'll look at some more details about that first, and then we'll go to the MATLAB screen and we'll try to write a function, and we'll try to write a code to implement the delta rule, and then we will also try to test that. Okay, so that's our objective. Let's start. So the first concept is we'll look at some of the fundamental terms. This will come again and again in any of the machine learning as well as the deep learning concepts, right? So the first concept that we are going to look today is the stochastic. It's called as a stochastic gradient descent. It's one of the term that comes in the processing, the signal processing algorithms, and in short, this is called as SGD. Okay, as the name suggests, the SGD, it's a gradient descent. You try to descend with some gradient, right? If you remember the concept of gradient from the basics of differentiation in mathematics, so how to obtain the gradient of any function? So just recall the concept of differentiation gives us the idea to calculate the rate of change, right? That itself is called as gradient, and you can differentiate a function to get the gradient of that particular function at a given point, right? So it's gradient descent, right? You try to descend on an error curve so that error becomes minimum. This is our idea, right? Previously, if you recall, there was a term called the error, right? How the error was defined? Error was defined like the target minus the output of a neural network, right? This is what we had studied. So we can apply the same thing to minimize the error, right? When the error is at its minimum position, then you can say that the machine has learned something, or if you are talking in terms of a neural network's weights have been updated to its optimum value, correct? So that is our fundamental idea now. So let's see what is this stochastic gradient descent stands for. Okay, so the stochastic gradient descent basically refers to this is actually we are trying to calculate the error for each of the training data. Right? For each and every training data, you calculate the error. We already have seen this, right? In every iteration, right? I give various data as my input, and every time you give input, right, you calculate an error, and depending on the error you decide what to do, whether there is a training that should happen now, whether you should update the weight or not, right? You will decide that based on this concept, correct? The error. So in the SGD, right, we always try to calculate the error for each of the training data, and right, then I will decide whether to uh, perform the weight updation or not, right? So I'll write and adjust the weights accordingly, right? For example, if we have 100 training points or 100 training data, SGD actually adjusts the weights how many times? 100 times. Every time you give the data, uh, the weight should get adjusted accordingly. Adjustment may be 0 or adjustment may be by certain amount, right? So that is the overall idea here, right? How many times you train, so many times the adjustment has to happen. All right. Now, the next point related to SGD is that as and when the SGD tries to adjust the weight corresponding to a data point, right, the performance of the neural network is going to be considered as it's undergoing the training process. All right. So that itself is what we are going to consider as a training process, right? All right. Okay. So the weight the weight adjustment for each of the training data, right? This means the artificial neural network is undergoing the process of training. Okay, now you see that the training is completely random, right? Why I say it is random? Because the weight adjustment or the weight updation is going to be a random variable, right? Because what is the amount of adjustment that you are going to do for the current input is completely random. It can be positive, it can be negative, it can be real number, right? It can be any natural number coming up, or it can be zero as well. You see, it takes any possible values, right? Ideally from minus infinity to plus infinity. So because of this one restriction, we are going to consider the whole training process as a random thing, right? Training process indicates the weight updation, right? Basically this weight updation is a completely a random thing. So we can make a statement that there is a word called stochastic in this, right? This is specifically we are using the word stochastic because, right, the weight updation, and when I say weight updation, it is actually referring to the training. Okay, weight updation and training is a random thing, is completely random. Right, now if you recall the weight updation equation, so SGD weight updation is as follows, right? So let's write another point over here. The stochastic gradient descent weight updation is given by the equation. The change in the weight Wij is equal to, remember there is a alpha coming up, learning rate, the delta I into the xi, right? So we use this particular equation, this. So what is the meaning of this equation, right? This equation implies that all the delta rules of our whatever we studied earlier. If you remember the previous section, we had studied about the delta learning rule, right? That value is going to give you the delta ij over here into the xj, which is the input, right? So the change, the error that is going to come, that is a delta value, right, from your from a particular layer and the input to that layer. So according to that, we update the weights for sure into a learning rate. All right, so this is the one very important concept that we need to remember whenever our intention is to use any machine learning, artificial neural network, or the deep learning concepts. Okay, they use this term for sure, what is called as SGD or stochastic gradient descent. Okay, moving forward, let's go to the next commonly used term. This is called as a batch. Okay, now always you have an option in training a neural network or any machine to convert the training data into a specific block of data, right? You let us say you have 100 data points, okay, but the training, for training purpose, you want to give 10 data set at a time as a batch. So what happens when you give the data in the form of a batch, right? This is what, see, whenever you, instead of calculating the error for each and every data, right, you now reduce the work of the neural network or the machine to calculate this error as an average of all the 10 data which you give. So for a batch, you can calculate the error. All right, so that's what is the use of batch, right? You try to cut your whole data points into several batches of equal size, and you give it for training every time. Instead of calculating the error for each and every sample, you can actually do that for the batch as a whole, right? So let's try to write the same thing what I mentioned now, right? In batch method, what happens, each weight update is calculated for all errors of the training data, and the average of the weight updates is used for the averaging of the weights. Adjusting of the weight happens through averaging function of errors of each of the batches, right? So that is what is going to happen. Let me write that point here so that it becomes clear when you refer. All right, so in a batch method, each weight update each of the weight update is actually calculated for all the errors of the training data, and the average of the weight updates is going to be used for adjusting the weights. So weights get adjusted by taking an average. Now this method uses all the training data and updates only once, right? The complete data set that you have given as a batch will be considered as one data point and gets updated only after that much of the data gets processed during the training. All right, so this is another very important point corresponding to this kind of Okay, right. Now, so as I mentioned, this particular method uses all of the training data and updates once, right? The whole batch, whatever you have, right, it's going to be considered at once for updation, right? So I'll write that point as well. So that is, this method uses all training data, all the training data, and updates the weights once. Okay, so let me show you a particular diagram corresponding to this, which says that how the complete data in a batch, right, will be used for training this. Okay, I'll just, so this is how it can be considered, right? You can see that you have a batch of training data, and the complete training data will be used for, right, the updation of the weight. But as I mentioned, it is through a what you call averaging function. It will be using an average, right? So let me write that equation now. So using this batch method, if you want to update the weight, then the weight updation, that is delta wij is equal to, now you see this is 1 by capital N times, I take a summation, I take the sum of all the wij's and I will consider the average of them as the actual wij. Okay, so this is, say, k is equal to 1 to n, right? Delta wij of the kth training data. All right, so let me explain this. Let me write this once. So here, where the delta wij of k, okay, so this particular value is the weight update for the kth training data. So k varies from 1 to n, which means all the first to n data points you are going to calculate the weight update. But you will not update the weight as and when you get that training data, but you wait for the whole batch to get completed. Once that is completed, you have all the delta wij's with you, right? That you take as an average of n values. Take the sum of n delta wij's and divide by the n value. So that's what is the meaning of this equation. It's very clear, correct? So, and the n is the total number of training data. Okay, so that is the next variable over here. This represents the total training data that you have, right, is represented by this. Now, so because of the averaged weight updation calculation, batch method consumes a significant amount of time for training, right? Because you are giving everything in the batch format. So you instead, in addition to calculating the weights for each and every data point, you are also calculating the average of certain what you call certain amount of data, right? At a batch at a size of 10 or batch with a size of 15, etc. Right? We are going to use this for sure whenever we write the codes. All right. So, but before that, this is going to be a common thing for every what you call most of the training algorithms. Okay. So slight variation is there. We will divide the batch into a mini batch, right? That's going to come up next. Okay, so let me write that point as well, related to the time taken for the training. That is, so okay, I can write because of the averaged weight update calculation, the batch method consumes significant amount of time. Overall, you can see that it's going to consume certain amount of time. All right, so that's the second term that will be used, right, during the ML DL algorithms, right? Then we will definitely see another term coming up. So this is called as, I think I just mentioned this term, that is mini batch. Okay, now we already have seen the stochastic gradient descent, right? What do you mean by that? How it can be used for the weight updation by calculating an error. Now there is a slight blend of this technique, right? That is what is called as the mini batch, right? So basically the mini batch selects part of a training data set and uses them for the training using the same batch method, right? You use batch was a bigger size. You even can consider the whole data set as a batch, right? That facility is there. But when it comes to the mini batch, you never consider the bigger size as a batch, right? Cut it into smaller size of data set, like just 5, 2, 3 points you consider as a mini batch, right? So use that as a batch and do the training. But the size is not bigger, size has to be smaller, right? So in case of a mini batch, uh, it selects a part of the training data set and uses them for training in the batch method. So you use the same concept of the batch, right? You will still calculate the delta Wij's, that is the weights of each and every input that you give within the mini batch. Calculate the average of that mini batch only and update the weights. So what happens here? It calculates the weight updates of the selected data and trains the neural network with the averaged weight update. All right, so let me write that point as well over here. So it means it basically calculates the weight updates for selected data for a selected data, and it's going to train the network with average weights. averaging the weights. So whichever weights they have been calculated over there, right? You are going to use the same weights to update, and this is going to be done by averaging those weights. Okay, now let's take an example, right? Say 20 arbitrary data points are selected out of 100 training points. So the batch method is applied for those 20 points and you adjust the weight. So let me show you a diagram corresponding to this so that this becomes clear. Right, I have a training data set and I'm not going to use the complete training data set for this purpose. I'm going to use a part of the training data set as a batch, and that batch, since the size of that batch is smaller, we are going to call it as a mini batch. Okay, you can see that the average of the weight updates for training happens only for 3 of the data which have been shown here. You are not going to use the complete data set. Okay, so now let us consider the mini batch method. When you are going to select an appropriate number of data points and you obtain the benefits from both the methods, right? Both the methods, in the sense, one from SGD. SGD is faster, okay, but batch is something like batch size is considered as a stable training method, because you are not using the weight update for of every training data, because some of the training data may give you a wrong amount of error, right? It is supposed to increase, but because of some ambiguity in the data set, right, you may get a wrong error calculated, right? So that will, if you instantaneously update the weights, it affects the weight updation algorithm, right? So what you do, if you go for the batch size, you are taking the average of say 10 data, 20 data, and so on. So the weight corresponding to them will be averaged, right? So uh, sorry, so whenever you are using the data in the batch, it is considered to be stable, right? SGD is faster because every time you check the update, you check the change in the weight and you update, right? That is faster technique because no averaging, you save a lot of time. But stable version of this is said to be the batch size. Okay, so if you use a mini batch, you have the advantages of both. So that's a very big plus point for us now. So let me write that point over here. Right, by selecting the appropriate number of the data points, right? We have right, I can write one can get the benefits. What are the benefits? The first benefit is the speed of SGD, right? Quickly you calculate the error and you can update. But since for every value of the every weight updation, for every time you calculate error, you don't have to update. You can take the averaging, because of which it is the batch size is if you use a batch method, it is considered as a stable, right? So that is the stability of, right, the batch method. Right. So whenever huge amount of data you have, for example, you use the deep learning algorithms, right? It actually manipulates a significant amount of data. So because of these two reasons, right? This method manipulates a significant amount of data. Okay. Now, let's try to look into this in a bit more detail. All right. Let us consider the word called as epoch. Right. If you remember the epoch, it is the number of completed training cycles of all the training data. How many times I have given the complete training data for the training purpose. Right. Now, let me come back to the batch method. The number of training cycles of the neural network will always be equal to the epoch, right? When in the normal batch method, because a batch can be even equal to the size of the complete data set. Most of the time, batch refers to the complete data set, right? So, epoch is equal to, right, the same thing, right? Number of epochs in case of a batch method, the number of training cycles equal to the epoch. All right, so let me write that once, right? I'm trying to compare the mini batch with the batch. All right, so in batch, right, the number of training cycles becomes equal, right? That becomes equal to the epoch, correct? Equals to epoch itself. How many epochs you have? The same thing, right? This is because batch method utilizes all the training data for a training process in general, right? So let me show you a diagram for that, right? Now, this means I am actually applying the following concept in a batch. So I have certain training data. All the training data I use for calculation of the weight update, and in the sense of by means of averaging the same, right? Once I do that, then I apply that to calculate the the weight update. So you can see this is what is happening. The complete data set I have, take the averaging, then you update. So this means the whole data set is being used for training, means that is epoch number 1, correct? So like that, I'm using this in case of a in case of the batch method for training. Whereas we have a contrasting idea that comes into picture whenever I'm going to use the mini batch. Okay, so this is important. This difference is, I should understand this difference clearly before I go further to learn or to use a specific what you call learning rule, and I try to implement that using MATLAB. Before that, I should need learn this. Okay, so let's go to the other option, that is in case of a mini batch. What happens? The number of training process for one epoch actually varies depending upon the number of points present inside each batch, right? So this is obvious because I have the number of batches. Batches will vary within one set of training data. Within one epoch, you have different number of what you call mini batches, right? So let me write that point now. So in case of a mini batch, the number of the training processes for one epoch varies. How it varies? Depending upon the number of data points in each of the batches. Right. So let's say we have n training data points in total. The number of training processes per epoch will be definitely greater than 1, because I have divided the whole data set into more than one pieces now. If you have divided the whole data set into two parts, right? How many times you do the training process? Training process will happen more than once, right? Which corresponds to the number of data that is present in each this thing. So this is the what I can say is the number of training processes per epoch is greater than 1, right? That corresponds to the batch method, and definitely smaller than n, that corresponds to the SGD. All right, so SGD uses n times. SGD updates the weight n times in, right, in an epoch, whereas the the other method, that is the batch method, uses only once. Batch method trains only once. SGD trains n times, but now what I can see is that the mini batch uses the value which is greater than 1 but less than n, right? So let me write that point here, which makes many things clear about it, right? So when we have capital N number of training data points in total, right? For this, for mini batch, right, we have two things to consider. The first one is that the number of training process per epoch will be greater than 1, right? So the number of training epoch is greater than 1, right? This is greater than 1, where 1 is the value of the number of training that is going to happen when you use a batch method, right? So this is the batch. So number of training method is greater than the batch method, that is for sure. At the same time, the same number of training per epoch, same thing, okay, this is same, is less than capital N. That's also for sure, right? Because n times it, if you have n data points, SGD will update n times, right? Every time you calculate a delta Wij and update your weight. So n data points corresponds to n updates. That is not going to happen in case of the mini batch. It's lesser than that. So it's less than n, where n is the number of trainings that's going to happen per epoch in case of SGD. So that is the comparison. Mini batch is between batch method as well as SGD. So we already called it as an advantage because it uses the fundamental characteristics of both SGD, which is faster, and the batch method, which is, right, stable, right? So that is what is about the mini batch. All right, now using all these concepts which we have studied, as well as the theory concepts we considered in the previous classes, right, we will move on for the implementation of our first algorithm, right, that is the delta learning rule, right, in MATLAB. So we want to implement the delta learning rule. So we'll go for a quick recap of this. So the delta learning rule, we actually calculate the delta learning rule uses. This is a quick recap. You calculate a delta I, that is the phi of your maybe the intermediate value Vi, or into, I just have to perform 1 minus the phi. Okay, I'll use a square bracket here just to differentiate between the terms. Okay, so this is equal to phi of Vi into 1 minus phi of Vi times the error, that is Ei. Okay, use this delta I to calculate the delta Wij, right? That is alpha times delta I times the input, that is Xg, and use this to update your weight. So Wij is equal to, this is Wij old plus delta Wij. I hope you are familiar with these equations, right? Because the same equations we had used for weight updation when we looked at the delta learning rule in the theory part, right? Okay, right. We are simply going to use this to identify, right, to write a code and understand how the classification is going to happen. All right, so let us try to give the data in the following format, right? Let's say we have two classes. Okay, so this is a classification problem. Right, I try to give two varieties of data and the machine has to classify, right? Classify them into, say, two classes. For example, if I have say like this, the first data is 0, 0, 1. This is my first data, and the next one, the second data is 0, 1, 1. If I give any one of these two, they should belong to, say, a class 0. Okay, at the same time, if I give like say 1, 0, 1 and say 1, 1, 1, this I want to classify into, say, class 1. This is my objective, right? This is the problem definition. I have, say, four data points, and I'm going to train the machine with these data points, saying that, okay, if this is given class 0, this is given class 1, class 0, class 1, like that. I'll train the data, train the machine, sorry, right? And at the end, I should have a machine with updated weights, right, and the biases, so that later on, if I test this with any of these data, it should be able to classify properly. This is my objective. Okay, so now we are going to use the specific algorithm called the delta learning rule. All right, so first let us see. I'll try to teach you the methods we discussed. First, I'm going to teach you how to implement the same thing. The delta learning rule will be delta only, but we'll implement first using simple SGD, right? Only SGD we'll be using, right? N times there are n points in our data set, means there will be updation of the weights that's going to happen also equal to n times, right? We'll see that first. All right, so let's directly this is my problem, but I'll do one thing. So before I start the MATLAB session, I'll just would like to make a modification in my data, wherein I would like to, when I give data to MATLAB, it contains even the class it belongs to. For example, right, so I'll perform the augmentation of the class into data. This is what I prefer doing, right? This is one of the method. Otherwise, you can actually make a complete new column or now a complete new target as a variable. Previous classes, the programs which we did, right? You see that there is a variable called target or output, right? So now instead of doing that, I'll actually include the class that a data set belongs to into the data set itself like this. So the class 1, right, will be something like 0010 because the last 0 I have added now because it belongs to class 0. So my first data sample is 0010, okay, where the last last bit I am representing itself is the class, right? So 0010 is one class as well as 0110 is the other class, is the same class, sorry, it belongs to same class because last bit is 0. Now the other two data points like 1011 I'll add because this is class 1. So my next data becomes 1111, right? So you see we have modified the data in such a way that the last bits represent their class, right? I don't have to create a new variable or new vector for identification of the class the data belongs to. That is not required now. Just look at the last bit, it gives you the class it belongs to. All right, so that's a new modification we are learning today. All right, so you can even give the data, enter the data in the using the following technique. All right, now let's go to the MATLAB screen and let us try to implement something on the MATLAB window. So I prefer writing a separate function for say, yeah, I would like to, I prefer writing a separate function for the SGD process, right? So I will create a new this thing, right? I'll use the command window itself to create my function, okay, to open the editor this thing. So if you remember, you can simply write the name of the file that you want to write, okay. So I would like to call that as I'm trying to implement the delta learning rule with the SGD, okay, delta SGD. I'll simply write, so it actually opens that. Now it is not there, so you can see that it actually has been created, right? From the fundamentals of MATLAB, we know this, right? So now you see, I don't want to write a function. I want to write, so I don't want to write something like, I don't want to start with the code itself for this. I want to write a function first. Whenever I call this function, this will calculate the SGD methods and updates your weights, right? So for weight updation, I'm writing this. Now, so let me call this as a function. So how to define a function in a MATLAB? You tell that it's a function, followed by you say that what is the output. Let's say W is my output. So W is equal to, give the same name as this. So delta SGD of, now you specify what are your inputs. I want to pass the weights, initialized weights, and I also want to I want to pass the input, and I want to pass say a variable called D. Okay, I want to pass these values to this particular function, right, where D is something like your final targets, right? I can even pass that as a variable over here, right? So this is what I am passing. Now I go to the learning value, right? So that is say alpha. We know that alpha value can be considered between 0 to 1, right? So I will define this as 0.85. I'll define alpha as 0.85, and let me define capital N equal to total value. So what is the number of training samples, right? That is equal to 4. Then okay, then what else I want? I have to pass these 4 values directly to the function, right? So for, right, I equals to 1 to n. Since I want to increment one by one, I don't have to specify the increment. The step size is not required. Even if you want, you can write 1 colon 1 colon n, which is same as 1 colon n, right? So for these many times, let me start with the, say, convert x is equal to, so let me assume that the capital X which comes as input is a row vector, right? I don't want a row vector, I want a column vector. So I'll write I comma all, take a transpose. Okay, then D, which is the target, target should be, I'll write D. Okay, this is capital D of K. Okay, so you can see that I'm extracting the inputs in the form of a column vector, and I will read every D as a target. Now, how do you calculate, for once you have these values, you can calculate the partial value, right? So V is equal to, I'm going to call V as my partial value. So that should be, how do you calculate? That is the weight vector, that is W, right, has to be multiplied with this X, correct? Right, then you can use a function to calculate a y. So I'll call this as a function. I would like to write the function by myself. I don't want to use the inbuilt function. So I will call that function as sigmoid. Okay, so sigmoid of v. You pass a v to that and you calculate the sigmoid value. So you see you got output. Now, once you have the output, you calculate the error, correct? So error E is equal to, how do you calculate the error? If you remember, this is the target value minus the output, isn't it? That's the error. Use the error to calculate the change in the weight, but before that we need what is called as a delta value, correct? So delta, how do you calculate a delta? Delta is equal to, this is the y into 1 minus y into error, right? So just now we wrote the equation. So this is y into 1 minus y times the error. Right. So now you apply the delta learning rule. What is the delta learning rule? It says delta W, right? Delta W is equal to the alpha into delta, right, into the input, correct? That is a small x. Then now you update all the weights, correct? So how many weights I have? I think I have let me say how many weights I pass. W is equal to W plus dW. This is what I'm supposed to do. Let me check whether this works at a later stage. So W is equal to W plus dW. All right. Then you see I'm going to end the for loop first, and then I'm going to end the function. All right, so that actually performs the, okay, let me just check whether we have written everything properly. So this is the function and define the alpha for n is equal to, I think this is I, my mistake. For I is equal to 1 to n, I calculate all this. Okay, so now you can see that we actually are using a function called sigmoid. So I have to write that function as well. Okay, I'll go for edit sigmoid. So it will open up Okay, there is a sigmoid already existing, so directly I think we can use it. Y is equal to sigmoid x, sigmoid activation function. Oh, no problem, we'll use it. Okay, fine. So you don't have to worry about that. Directly it will be used. So sigma is already defined. Let's go for the program which we want to write. Okay, so I will call I'll actually create a new program now. So this was just a function. So go to the edit. I'll call this as a test delta SGD. Whatever the SGD function we have written, I'm going to test that. All right, so I'll go for edit. So do clear, close, and CLC. All right, so if at all something that is existing in the workspace, it will give. Close all I will give, because every window that is open other than what is required I want to close, right? So you use a close all function, right? So then CLC. Okay, now let me start with my input data, right? So input data, say x is equal to, I'll write the one by one function which I have given. So first one was 0 0 1, and the next value was 0 1 1, and then I think I had 1 0 1, and the next data is 1 1 1. All right, this is the first x. Then I need to talk about the d, which is the target value, right? If you see the first value is I think this is say 0 0, then 1 1, correct? Okay, so that is a d. Then I create a weight vector. So let me assume that I want to create it at random. Okay, so w is equal to, if you remember the basics, we have a function called rand, right? So I make it more random. So 2 times I'm going to use rand, create a random number, 1 rows, 3 columns. Put it, say maybe I'll subtract 1 from that. Maybe I'm simply trying to make it more randomness into picture. Okay, so let's go for the okay, let's go for a for loop, right? Because I want to pass these inputs, right, so many times, the number of times equal to the number of epochs, right? So let me define epoch. For epoch is equal to, say, 1 200. Let me start with this. Let me check whether this works out. Okay, what happens, right, when I train this machine 100 times, what happens to the output? I want to show you that the effect of training a machine with more number of epochs. All right, so let's try that. So this is for epochs is 1 to 100. What happens, right, when you train, you get the updated weights, correct? So the weight is equal to, call the same function which you written earlier, right? This is delta SGD of w comma x comma d, right? So I'll write that over here. Okay, so let me write. So w is equal to the delta SGD of, right, what are the values? That is w comma x comma d. I pass this. So internally it actually updates the weights, it calls the function so many times, and end. So what exactly is going to happen here? I'll try to write it as a comment. This is a training process. Okay, now let me check. After the training, I have to check whether the machine learned or not, correct? So so how do you do that? Let me define n equal to 4 once again. I give 4 data, right? I give the 4 this thing. So I'll go for say, I'll use a for loop once again. For k is equal to 1 to n, Let me define the x now. So small x is equal to, I'll give one by one. Okay, so that is capital X of k comma all. Convert that into a column vector, right? Then calculate a v, because this has to happen every time you do this. I'm just calculating my output now. So v should be equal to w into x. It's a simple matrix multiplication, and the y should be equal to the output. Y should be equal to what? Should be equal to the sigmoid function. Are you okay? Right. So do this output I want to show. That's why I'm not going to put the semicolon at the end. And let me write end. Okay. So this is nothing but my training. If I run this, it is sufficient. It will go to the other function, executes that function, and comes back. Right. So let's try this. Hope this works. All right. Okay. There is an error in delta SGD line number 6. Okay, it should be I. Sorry, my mistake. I actually have started with I, but later on I gave this. Okay, okay. Save this. Now come back and run this. Argument incorrect. Sigmoid of V. Okay, let's see. I think that's a built-in function, so maybe a difference in terms of there will be a difference in terms of the way you give the input. Okay, I'll give for sigmoid of X. Sigmoid of X, right? Correct. SIGMOID of V. It says missing argument or incorrect argument data type, call the function sigmoid. It's correct, right? V is already calculated and I am actually passing the sigmoid to V. V is equal to W into X. It looks fine for me. Just a second, let me verify once again. V is equal to W into X. Okay, this I think it's a capital W into small x. That is right. Let us see what comes as V. Okay, maybe in that case I should be able to trace out. Let me run again. Yes, V comes as this. Let me check the sigmoid of that value. That is minus 0.0292. Check for missing argument, incorrect argument. It says it's not able to calculate the sigmoid value for this number. All right, let's just verify. Or else we can even write our own function. Why to worry about that? Okay, let's check once again. Edit. Sigmoid. So it says that you are calculating y is equal to 1 divided by 1 plus e to the power minus x. It's correct. So you are supposed to calculate the same thing. Okay, let's do one thing. I think they're writing something else over here. I don't see the e to the power. X data ft is equal. No, let's do one thing. I'll write a complete new code for this. Okay, I'll call that as my sigmoid, because sigmoid already exists. I cannot use that. Okay, I'll call here as well. This is my sigmoid, and I just have to write another function. That's all. Okay, so edit my sigmoid. It creates that particular function now. So what I have to write? So simply this is a function y is equal to my sigmoid of some parameter that you pass, say call x, right? So what I need to calculate, I simply have to perform that calculation. So that is say y is equal to, it is 1 divided by, I'll use a bracket, this is 1 plus exp e to the power minus x, right? This is what I want. I just want this to be returned, right? So end. Just save it. All right, let's see now. Should be a dot star, I guess, because y has many terms. No, delta error is also 1 minus number of columns in the first matrix matches the number of rows in the second one. Okay, let's see that. Y, this is in line number 10 of SGD. Y is a single value, error is also a single value. So what is happening? Let's just check. Okay, V has 3 values. Error is calculated, so there is error in line number 10. So that is this, delta is equal to y v is equal to a single value, so we get y is equal to sigmoid of v. Okay, let's trace this. What's going to happen here? Let me remove the semicolon so that we can trace out. I think there is error in this because of mismatch in the size of the arrays, right? So let's write this. So let me come back. Now you check. So see, y has 3 values. So x has 3 values. D has only 1 value. D has one value, we have this values. So X has a single value, okay. Delta comes as minus, okay, that delta is calculated over here, I guess, right? So okay, weight is randomly calculated. Delta is minus, the delta is calculated first. Let's run again because I want to clear everything. And now you see X is equal to, okay, it comes to this because 0, 0, 1. 0, 0, 1 is my first variable, right? So you see this is 0, 0, 1, X is there. Then the desired value for that is 0, so the 0 is there. Then V is calculated. Let's come inside this function. So you calculate a V. V is equal to W into X, right? So weight is a weight has three values. It can be W into X. Okay, right, that's fine. We get a value over there, that is V. Sigmoid of V comes over there, that is the Y value, that is also coming up. And then we have this Y gives you the error E, right? D minus Y, you get a value error. Okay, now there is a problem with which one? Problem with the calculation of the delta, I guess. No, you already have calculated the delta. Okay, no, that delta is coming up. There is delta. Once again, you give the next input, that is X equal to next one, that is 0, 1, 1. Okay, once again the desired value is 0, so D is 0. The V is equal to, okay, now there is a problem. The V comes to be three values. Okay, let me make a change. Dot star. Okay, I think here, sorry. V is equal to dot star. Okay, now let us check what's going to happen. Okay, since you multiply dot star, all the three values are going to come up. All right, let's do one thing. You take a break of 10 minutes. I'll rectify this issue meanwhile. Okay. Okay, now the updated code is like this, right? Instead of simply writing W is equal to W plus DW, I'm trying to update the weight corresponding to the DWs we calculated. Okay, so now the first weight is equal to older first weight plus the update corresponding to the DW, because if I don't do that, right, it will try to add the same values to everything. It creates more columns in my matrix. DW matrix becomes a larger matrix, because of which we had some issues with the weight updation, right? Now let us check this, right? So I'll come back to this. Okay, in the main code nothing changes. Okay, everything as it is. Only here I made the changes, like I removed the one line I wrote earlier and I replaced it with three lines. Okay, previously it was W equal to W plus DW. Now I changed to W of 1 equal to W of 1 plus DW of 1, and repeated for 2 and 3, because there are three different weights needs to be updated. Okay, right, now let us run this. Yeah, so you can see that the Y value comes to be, right, okay, there are 4 times I'm giving the inputs. So okay, let me show you the weights over here now. So initial weights are this. Okay, so this, say W. Okay, capital W. This is the initial weight. and after this let me display that this once again the W. Okay, this is the updated weight. All right, and the second times you whatever you display is that, right? And then we get the Y values like this. Okay, let me do one thing. So this is Y of it's a variable K. Y of K is equal to this, and then I display Y at the end. I don't want to display like one by one. Let me display the Y at the end. Okay, now I think the result becomes more clear. So you see, I can see that W is equal to this, correct? Which means this is the first weight, initialized weight. I am initializing randomly. See, W is equal to 2 into random of something, right? I do it like this, right? So I'm getting, these are the initial weights, right? After training, right, that is after doing this training process, you display the W, right? So that is the second W. You can see this is the optimized weight, right, after 100 epochs, right? And the final outputs are like this, right? So output is equal to 0 0.12, 0 0.10, 0 0.92 and 0 0.90. If you make an approximation, mostly this can be considered as 0 0 1 1. All right, let's run this once again. Every time you should observe that the weights, initial weights will change. Okay, let me write something else. So let me write a disp initial W equal to, okay, similarly I'll display this is final. Okay, let's run once again. You can see that the initial weight is different now, and the final weights are also different now, and you have a different outputs coming up, right? So their values are close enough, but again you can see previously it was 0 0.12 and 0 0.10. Now you see 0 0.11, 0 0.09. It will change because you are initializing weights every time you change the initial weights, correct? It's randomly generated, right? So as I already mentioned in the theory part, it's very clear that whenever you try to initialize with any possible value, right, it will train. It will try to train and it will come to the optimum value. Okay, now let's do one thing. Instead of 100 epochs, let me reduce this. Okay, let me do only say 25 epochs and see what's going to happen. Will the result come closer to this or will there be any error? You see now there is actually error, right? More error because output is not close to the required value. You see, this is 0.25, 0.25, 0.8 and 0.8. So as the number of epochs you reduce, you see you are not going to get the optimum output value because your final weights are not coming closer to the required value. Previously you see here, this was something around 4, right? The first value was around 4, negative value is minus 1 something. So I'll slightly increase this to 50. Let's see. Okay, now you see, right, it's better than the previous one but not as good as 100, right? Now let's go further. Let's make it 500 and see what's going to happen. I'm expecting much closer value, much optimum outputs, right? Because there is more training happen. Learning curve is going to be more steeper now, right? That is obvious because now when I say I'm increasing the number of samples to, sorry, number of training, that is 500 epochs, right? I'm doing the epochs of 500. So same data set will go to the machine again and again, 5 times more than the first case where we considered 100 samples, right? So because of this, now I am expecting that I'm going to get a much better result, right? So let's check that. So see, final weight is 6 point something, right? 6 point something minus 0 0.22 and minus 2.9. You see this is more closer to the required values, 0 0.05, 0 0.04, 0 0.96 and 0 0.95. You see the first two classes are coming closer to 0 because we initialize, I want first two inputs to be 0, right? To be classified as 0. Last two inputs to be classified as 1. It's trying to do that, right? And then let's go further, right? Let me make it a much bigger number. Maybe I want to give it 1000. Okay, let's see. So this is much closer. You see, Instead of 0.05, I'm getting 0.03 and 0.02, 0.97 like this. So if at all I increase this to say 10,000, maybe I will come more and more closer, right? So as the training increases, right, that's what we say that in case of ANN, ML, DL, you have to give the training, you have to perform a training as many number of times as possible to come closer to the actual required output, right? So let's go one step further, right? Let me increase this to, right, you can see it is very close, 0.0033, 0027, 99 and 99. Okay, it's going to take that, it will take time. Now if I increase this by one more zero, output will come after some time. You will observe a delay. You see it's running, still running. Now you get the output. You see there is a delay because you increase the training by 10 times than the previous case, right? So 0.00, as the training increases, right, the number of samples you increase during the training, right, you get you keep getting much better results. This was a very simple case of classifying 4 data samples. But when it comes to the classification of a, say, handwriting recognition, I'm writing A and B, and I want to teach the machine that, okay, this is A, this is B, class 0, class 1. So training is going to take much more time than this, right? So let's try one more time with a much larger value. It's going to take more time, and I'm expecting much closer answer. Okay. So it will take some time now, because previous was taking some 5 to 10 seconds. This will take 10 times than that. So it will take time because I have given a huge value for the calculation purpose, but I'm expecting very close answers. Maybe, right, I can stop the training over there. I don't want to go beyond this, right? I don't want to increase this beyond this point, right? It's going to take time, more and more time. But I'll tell you a much easier method after once I get a result now, right? So you can see it's something like very optimum, right? You got your required results, and you can see the final weights, right? Initial weights are something like this, but the final weights are coming to these values, right? Whenever you give these values and do the calculation using the sigmoid function as an activation function, right, you are going to get this. Okay, but let me come back to the simple case. Like, say I use simply 100, right? When I run this, there is error, right? You can see that final weight is coming like this, and I still have what you call the y values like this, right? They are not closer. But how to make this y, uh, how to see the y as zeros and ones? I told you one technique, right? You can do a modification here itself, saying that y is equal, you can convert this into logic, right? Yes or no type you can simply make. What is that? Set a threshold midpoint of this. One is 0, one is 1, right? My two classes are 1 and 0s, right? So I can make it a logical answer by saying it is 1 and 0. 1 is more than 0.5, 0 is less than 0.5. So I'll just check y is equal to y greater than 0.5 or not. Okay, now you see without any error, I can see that, you see, your answers are 0, 0, 1, 1, but it is logical. That's fine for me, right? So I'm able to, without going for a large training happening, without wasting the time, with even with the small calculations like this, I can get the zeros and ones at the output. That's fine. That's just a logic. Okay, but mathematically, if you want to go with the ideal values that should become at the output, means what you are going to do, you will simply go for higher, larger number of training. You increase the training to a larger value. I hope that is clear, right? Okay, now let us do one thing. Let us try to implement the same logic, but I don't want to use the simple SGD method, right? This is fine. I hope you understood how the simple SGD works, right? Updation of the weight happens every time. Every time you train, weight gets updated, right? That's what is happening in the delta SGD method, right? So you see the delta is calculated for 1 to n times. For I is equal to 1 to n, every time this loop runs, you calculate a delta, you calculate a dw, that dw will be used to update your weights. So weight updation happens how many times? N times for every loop. Every time this loop runs, you can see that the weight updation is going to happen. All right, now my intention is that I don't want to do this. I want to go with the batch technique. Okay, so let's go to the batch implementation, right? Only this code I change, right? In my uh, algorithm, all I want to change is this delta SGD method. I don't want to use the delta SGD. I want to use what is called as the, it's a, uh, maybe I'll call it as a say delta batch. Okay, that should be more meaningful, right? So I edit delta batch. So new function I want to write. So this function should be, it's a function, so I'll write function. What's the output of the function? It should be the updated weight. So w is equal to, what's the name of the function? delta, that is delta delta batch. What you pass? W, I pass my input, I pass my desired outputs, right? This is what you're going to pass, right? Then as usual, define what is the alpha value. Okay, yeah, actually I can even change the alpha value to change my parameter. Okay, now I'll define it as maybe 0.9. So previously I took 0.85. Maybe you can change this. Okay, so that is another option which you can change and obtain make some changes in this. Right now I will actually make a group of say uh, three numbers. Every time I do the update, right, all the three weights will get updated. So I need a sum, I need a variable to save the sum of the weights, right? Because see, the idea here is that you give the complete data set as input, right? Every time though you calculate the weights, weight updation will happen only once at the end, once the whole data set is completed. So you see, you need a term to hold the weights, correct? Sorry, to hold the sum of the weights. So every time I calculated dw, I keep on adding that to the dw sum variable. So let me create that variable now. So I will call this as say dw sum is equal to, initialize all zeros. How do you initialize all zeros? It's zeros of how many values you have, you write. I have 3 values, I want 1 columns. So it's a 3 cross 1 variable. Okay, then number of inputs equal to 4. Then for I is equal to 1 to n. Okay, let's do the same thing. This is pretty much similar to the previous one. So x is equal to capital X of I comma all, take a transpose. Then d is equal to capital D of I. Okay, rest most of the things will remain same. I will calculate a v now. So v is equal to, can you remember what is v? V is equal to w multiplied by x, right? And we have a y value coming up, that is nothing but what's a y? How do you calculate y? This is using my sigmoid function. Use my sigmoid and use a value of v and calculate y. And once that is done, calculate the error. E is equal to the d value minus the current y value. Okay, then do the delta. Delta is equal to y output y into 1 minus y times the error. Okay, standard, the delta learning rule has this equation, right? Then now go for a dw. Dw is equal to same equation, I think alpha into delta into the input, right? So that is x, right? Now you see, I don't do the updation. I don't want to do the update, right? Instead of that, every time I calculate a dw, I'll add it to the dw sum. Dw sum is equal to dw sum plus the dw. Okay, this is what I want. Later on, I'll simply perform the averaging and then I add. Correct. So to the end, the for loop is over because it calculates the sum for 4 times. Whenever the 4 of the data is given as input, it calculates the weight updation value, that is dw, but I don't update the w of 1 is equal to w of 1 plus that. I don't do that. Instead of that, what you are going to do, you are simply calculating a sum. Once I come out of this loop, right, what I do, I take the average, right? So I am out of the loop now, right? What I'm supposed to do, will create a variable, that is dw average, right, is equal to dw sum divide by capital N is the number of this thing. Okay, now you see I calculated the average. After you calculate the average, now you do the updation, that is capital W of 1 is equal to capital W of 1 plus, I have to perform, it's just dw average, right? The average has to be updated, correct? Average has to be added, so dw average of 1. Repeat this, so w of 2 is equal to w of 2 plus dw average of 2, then w of 3 is equal to w of 3 plus dw average of 3, right? Now you see I'm actually updating the weight after the complete batch is completed, right? Once this batch training is over, I calculate the average and that average value I'm trying to update. All right, so like this I'm trying to do the updation, right? Updation changes simply like this. Okay, now so let's write the code corresponding to this, and I'm going to call, say, this code as let me give a different name to this. Already we had given a name like test the delta SGD, right? Okay, so I'll write edit test delta batch. Okay, let's quickly write this. Okay, and let me define my input, that is capital X is equal to, so if you remember the same variables that we are going to pass, the values were 0 0 1, then we have 0 1 1, then 1 0 1 and 1 1 1. That is the input. Then we have the desired value written in this form, so this is 0 0 1 1. Okay, then we have the w weight is equal to, I'll do something else now, so say 0 maybe 3 times random values 1 comma 3, oh sorry, should use a bracket, 1 comma 3, say minus 0.5. Okay, this is the random value weight. Then go to the epoch, right? So for epoch equal to number 1 to 100. This is capital W is equal to, simply call the new function. Okay, so that function is delta batch. Pass the same variables. What do you want? What do you have to pass now? The weight, already defined weights, and you also have to pass the x value and the desired value. Okay, this is passed, and that finishes the training is over here. Then I'll go for the testing phase, right? So I define now, say capital N is equal to how many values? 4. I want to give 4 inputs and test this. Okay, and say I'll use another for loop for, say, k is equal to 1 to n, x is equal to capital X of, this is k comma all transpose. Then use this k to calculate a v. V is equal to, how do you calculate v? V is equal to the weight multiplied by x. Use this v to calculate a y. So y is equal to my sigmoid of the variable v. All right, so this is calculated. I'll put this into an array so that I can y of k, I can make it y of k, and then you display the y. Okay, so let's define the w's here, and let me also, I don't want to display anything here, but I want to display the w over here. Okay, so let's try to run this. So you can see the initial weight is this. After 100 epochs, weight come to this, and you can see that the values that you are going to get at the end is 0.24, 0.18, 0.86, and 0.81. Right. So let's increase the epochs to 1000 and run. So now you see it's slightly coming closer, right? Increase this further, right? 0.02, 0.01, 0.98, and so on, right? You can further increase this by another digit. It might come much closer, right? You can see that, right? So you are getting, so previously in the previous SGD technique, in order to reach a 0.00 up to 2 decimal points, we used actually more number of more epochs, right? We had a huge number of epochs to come to this level of answer. But because of this averaging that is taking place, you are able to come to the answer slightly faster, right? So if you do the batching technique, right, that is actually, it looks like slightly more efficient compared to the SGD as it is. All right. So that's the one thing that we can learn from this particular session. Okay. So try to run this. I'll share you these codes. Okay. So that you can make some modifications in this and try by yourself various options, right? So whatever codes we have written today, right, I'll share you.